Well, you're probably hitting the letter I and not the number I. The number I is within the pi symbol there, but
What is it?
I don't even know how to do that.
you need to.
I wish I did.
You need to know how to do this. Listen, okay? So square root of negative 100. I saw a couple people do this, and I want to show this and applaud this because it's valid. Is 100 the same as 4 times 25?
Yes.
Yeah? What do I still need to multiply by this though? Negative 1. And notice they chose these factors because both 4 and 25 are what? Perfect squares. Those are things I can take the square root of, right? So, found factors that are perfect squares. Okay? So, remember, I can rewrite this one radical as how many radicals?
3.
How many factors do I have? 3. So how many radicals?
3.
3. Square root of 4 times the square root of 25 times the square root of negative 1. What is the square root of 4? Square root of 25. Square root of negative 1. Or 10i. Now I'll point out, you could have made your life easier. Because isn't 100 already a perfect square?
Yeah.
Yes.
So that's the route I would have gone, but notice it doesn't matter which one you go. You get 10i. So there are multiple ways to tackle this number 1 here. Alright? Either way you go, you just need perfect square factors. That's it. I want to see that you know how to simplify these radicals, which requires thought, not just typing into the calculator. Typing it into the calculator does not give me understanding, and it's 10i, not 100i, because I got to take the square root of 100. So what's a factor of 75 that's a perfect square?
25.
25, right? 25 times what gives me 75?
3.
And I still need the...
Negative 1.
Remember, whenever it's a negative radicand, I need a negative 1 because the square root of negative 1 is I. So square root of 25 times the square root of 3 times the square root of negative 1. Every factor gets its own radical. And what's the square root of 25? Square root of 3?
Nah.
That's 3 squared.
Oh, my fault. 3 squared.
It is the square root of 3, right? That's an irrational number. It's not a perfect square, so I leave it as the square root of 3. Square root of negative 1 is I. There is the simplified expression using I. Come on, remember, it's before the test or even after the test. Next unit we'll apply these ideas. So if you learn it, you learn it. That's all that matters.
Well, just not put my grade in, please. Because I can't afford
I won't. What are your questions before I continue to number 3?
You
might as well go on cancel that.
It was meant for
Continue
number 1, number 2.
I ain't gonna lie.
Number 3.
3 was probably.
Alright, have lunch, we'll come back and we'll go over this. Man, the one is so much fun.
The one so much fun?
Yeah,
This kid, I bet you I won't walk back in this classroom.
I bet.
We can bet $50 right now that I won't walk back in this classroom. I promise you I won't walk back. Like, it's crazy.
Roots. Which one?
F of X.
Why did f of x have imaginary
Because it's the
roots?
only one.
Because it don't intersect with the x-axis.
So don't forget, how many roots does every quadratic have?
2.
It has 2, but I can't see those 2, right? So these 2 roots are what?
real.
Real roots.
I thought y'all just said they were.
I mean, imaginary roots. I'm tripping.
Yeah,
So these 2 roots are imaginary, right? It does not
Exist.
intersect
Oh, the x.
the x-axis. So remember, they exist. That's the whole thing. They exist, they're just what type?
Imaginary.
Imaginary. They don't exist in the real number system, right? But they exist, 100%, through and through. I did say here, describing the types of roots for each function will provide greater evidence of understanding. So, for example, right here, Mel was asking about this, I think, earlier. What could I call these roots right here? Thank you.
Real.
They are real.
X intercept?
Do we know anything more beyond them
Complex.
just being real?
You talking about intercept?
Yeah, they're x-intercepts, but that's because they're real.
Oh, they're
Say that
integers?
again.
Oh,
Integer.
yeah.
Those are integer roots, aren't
They
they?
hold number 2.
So,
Oh, wait, no, no.
that's a whole number.
It's a negative.
So what we could say here is that these are two different integer roots.
Yes.
Okay, so these are two different integer roots.
And then a 0 hold.
And then so like here though, remember how many roots are there supposed to be?
2.
So why do I only see one?
That's the vertex.
It is the vertex. There's also a name for this. I don't know that I've talked about this one in this class, but it's actually pretty straightforward. How many roots do there have to be?
2.
2. And I only see it right here, so this is what we're going to call
Double
a
root.
double root.
Oh, yeah.
So, literally, x equals 4 twice. We're going to talk more about that next unit, but we just call that a double root. It's the same root twice. There's always got to be 2 roots. Say again. Say again. Just positive 4. So like you can see it.
Pumpkin.
It is literally just positive 4. You don't have to do this for me, but this equation would be this. X minus 4 squared, or x minus 4 times x minus 4.
Right.
That's showing that my roots are the same. Those roots are both 4. That's called that double root. We've seen that a few times. You don't have to know that level of detail. All you have to know, though, is how to identify the imaginary. How do we know these are imaginary?
They don't touch the x-axis.
Doesn't intersect the x-axis, right? That's it. We got to know that detail, though. If that function does not intersect the x-axis, it has imaginary zeros. I can guarantee you this. There will be a question about that on your test.
I was right.
What?
I was right. You say it again?
No.
With double root
There
stuff?
will be this question on the test about imaginary zeros. Okay.
Oh, man.
So, listing all the words from the box that describe each given number. Remember, this is not in Mathia. If I were you, I would definitely be practicing and getting ready with Mathia. This is on the Frere model that I gave you for check your understanding questions. A is pretty nice and straightforward though. What kind of number is A?
Imaginary.
Imaginary.
Why is it imaginary?
And the complex.
Also
It's got the I.
complex.
So let me ask you
Complex.
this. If I were to tell you 5 minus 2i, what type of number would that be?
Imaginary.
Imaginary.
Just imaginary?
Wait,
Complex,
real and
but
imaginary.
Complex.
So imaginary and,
Complex.
so why is it not an integer?
Because
It's
of
got the I with it.
So, and also I want to remind you, how many numbers are actually right here?
3.
2.
The what I just
Three.
boxed?
3.
Yeah,
2.
I
Two.
don't know.
5 and 2. Negative 2I.
Mm.
Negative 2 is with the I.
So, let me remind you this, and this is why I
Hard
brought this
try
question up.
What is he talking
Listen.
about?
Okay? Just 5 would be an integer, a whole number, a natural number, right? Just negative 2i would be imaginary. But don't forget, like, that is only one number. 5 minus 2i, that's imaginary. Think about 5 minus 2. That's one number, because what is 5 minus 2 equal to? 3. So even though I have 2 numbers written, I can simplify it. Well, here, can I simplify this?
No.
No. So this is just an example, but I want to make it clear that if you have a real and an imaginary part, notice how I said a real part and an imaginary part for how many numbers? This is how many numbers?
2. Wait, oh, 1. 1 4.
It just has a real part and an imaginary part. So there's an imaginary number and a
Bro. I'm the complex.
complex. Every number is complex. So real or imaginary from there. But imaginary and complex, that's it. Okay? Negative 18 divided by 2.
Complex.
Complex.
Real number. Rational.
So complex. And so here's one thing I will recommend. You can look at up here and check to see it. So like, is it real?
I think it was real.
Yeah? How do we know it's real?
Because the negative 18, the 2 is real. It doesn't have no I with it.
There's no I, okay? So it's real. Is it an integer?
It's natural, right? No.
It's not an integer?
No integer.
Complex.
No integer.
No integer?
Unless you simplify.
Oh wait, Could we simplify this?
Yes.
So negative 18 divided by 2 is,
-9.
so that is equal to -9, so is it an integer?
Okay, yes.
Okay.
So if it can simplify, simplify it, and yes, it is an integer for sure.
Oh, I did
But
that.
how
And by the way, you can use the words instead of the letters, right? Real, integer. Is it complex?
Yes.
Yes.
Okay.
And it's a whole number.
Is it irrational?
No.
Why not?
Cause cause
It
how is it gonna be a
repeat.
regular? I mean, a rational
repeat.
number if it's a regular. I mean, if it's irrational.
Huh?
How's it gonna be irrational if it's a real? It's a, hold on. Oh, I just confused myself.
How's it gonna be an irrational number?
Listen, guys, y'all gotta remember, I do want you to justify and understand these things. Like, why is it not irrational?
Because it's repeating.
Because it's what? Written as a,
Okay.
it's written as a fraction or a ratio of integers. You can also point out, like, most of the time, most of our irrational numbers are what kind of numbers?
No, David.
I was like, how we know? if it's
Not just
integer?
decimals.
Repeating.
Repetitive.
Remember, not repeating.
What? They don't. Oh.
Remember these square roots
Yes, they're not
and
working,
these
right?
cube roots? Those are irrational. Most of the time, when you're dealing with square roots, cube roots, unless they're perfect squares, perfect cubes, it's gonna be irrational. Also, remember, if it is a rational number, the decimal does what? It either stops or terminates, or it
You can't go.
repeats.
Oh.
Not it keeps on going.
I messed
So
up.
decimal terminates.
And is that terminate the little line at the top of it?
No.
Why?
Oh,
So
Mr. Kenny.
repeats would be 1.3. Repeating, saying it's 3. That's repeating.
Okay.
It's repeating.
Terminating means it stops.
Yeah, I'm really overstepping.
It just makes sense.
Overstimulating.
Yeah, but I was like,
I think I need to go home, Mr. Kenny.
but my ear keeps going, Mr. King, Mr. King, and like, I keep forgetting, you remind me of something. No, that's like,
So is it irrational?
Yo, I get no.
No,
No, it's not. It's rational.
what's wrong with you?
Because it
You
terminates.
just told us.
That decimal what?
Terminates.
Right, it's -9.0 or just -9. Like that decimal terminates. It's a rational number.
Indeed.
More importantly, I would point this out. One, hey guys, if it is an integer, could it be irrational? Huh?
Wait, what you said? My fault.
I said, if it is an integer, could it be
Oh,
irrational?
irrational.
No. It certainly cannot.
Look, let's make sure we're looking here.
Move.
Look, here's my irrational numbers. Here's my integers. You see on two different sides?
Yeah.
So if it's an integer, it is rational,
I said it can't.
real, and complex. Remember, if you know that chart, if you learn that chart, you identify the most specific thing and follow it all the way up. So, it is real, is an integer, it's complex, is it anything else? I heard whole.
Rational.
Is it a whole number?
Yes.
Yo,
Why do you think that?
Because it's the same.
I hope
No,
you just
whole
say because
numbers.
it's
Whole
same
numbers
name.
is 0, 1, 2, 3, 4, 5.
Wait, say that one more time. Whole numbers are what?
Start for 0.
They start at 0.
Alright.
And
So
integer.
is this -9 a whole number?
No.
So we gotta know where the whole numbers start. Remember, the whole idea of the integers is that is my whole numbers and their opposites.
No, I'm not touching.
So whole numbers and opposites. So if it's a negative, is an integer, it's not whole. Someone said rational, we already talked about that, it is a rational number.
Indeed.
Free my daddy, man.
So integer, rational, real, complex.
Where's that cube?
Rational. I don't think I ever talked about it, Todd,
Thanks like that, bro.
why, but a ratio is division, right?
What's that
Has a
zero?
division there. And the word quotient means division. So that's why we use Q for rational.
What's that zero?
Huh?
What's that Z?
Is it?
Integer. Remember I told you it came from that German word Zahlen, I think it was, That means number, so we use Z for integer.
Sandra missing real numbers.
So natural, and, by the way, do you have to use the symbols?
No.
No, you can 100% use the
Just write the
words.
word. Yep.
Remember, that's why I said this is the real minus the rational. If I take away all the rationals, I'm left with irrationals.
What if you don't get rid of all the rationals?
Well, then you don't have all the irrationals.
Don't have to get-
Alright, square root of 19.
Complex.
Complex and
Whole number,
irrational.
integer.
Yeah.
Shout out to bro, man. All right.
You're missing one.
Rational.
Pussy so long.
Real.
Real.
I say, remember guys, the whole thing is irrational are the reals without the rationals, right?
Oh yeah.
So it's gotta be
Real.
real.
Gotcha. You made my hair.
Wait, what?
Okay, so real.
I mean, does it have an I? Does it have a square root of a negative?
So what's a
Oh
natural?
yeah.
So it's a real number. Say again.
So what's a natural number?
So remember, the natural numbers are where you naturally start counting.
Because you have simplified. Midikin.
So
Complex
remember, the
and
whole
irrational.
numbers start at 0. The natural numbers start at 1, where you naturally start counting. So there's not a lot of difference between natural and whole.
Because you all have simplified, brother.
Irrational.
The square root of 19.
Yeah.
What are the factors of 19?
It's like 4.3, 5 something.
Yeah, but that's irrational, isn't it?
You can keep talking.
So remember, the only factors of 19 are 1 and 19. Are either of those, or is 19 a perfect square? No. So that's going to be an irrational number.
Make sure.
Okay. Questions about this before we move to the back side? Alright, so guys, I need y'all to pay attention to this. Because I saw a lot of people on number 5 making a huge mistake when I walked around the room. What am I doing between these two numbers?
Subtraction 9 and 4.
Please notice how we just said subtracting, right?
Yes.
Do I need an area model to subtract?
No.
Yes, sir.
That's only to what?
Plus 5.
Oh, man.
Area model should have only been on here.
I sure I'm gonna mess myself up.
So was I just supposed to combine like terms?
Yeah, it's 9i minus 4i.
5.
It's 3. Well, when I subtracted negative, what do I end up doing? So what you could have also done, if you wanted to, is distribute here. It'll get you to the same exact spot. Minus 4i plus 1. Just make sure you remember, when you subtract a negative, you end up adding. And I just rearranged it so my like terms were with each other.
Look, I was doing that, then I thought I was wrong. I had to think.
9i minus 4i, what is that?
3i.
5.
5i. I'm tripping.
3 plus 1? Now remember, I don't recommend stopping here.
I put negative 4, Miss Kenny. So I did 9
But
minus
3
4
plus
3
1.
minus negative 1.
What?
I did 9 minus 4, I did 3 minus negative 1.
Bad grade. with my
Right,
money.
3
Change my head.
minus negative 1 is 3 plus 1. When you subtract a negative, you end up adding. But I will point out, I personally would not stop here. Which part always comes first?
Subtract. Multiply.
Real comes first.
Yes.
You look in the textbook, if you look at most mathematics, we put the real part first. A plus BI is that format. So do not forget real then imaginary. Do we understand why it's 9i minus 4i and 3 plus 1?
Understandable.
So remember,
Wait, no.
add your real parts together, add your imaginary parts together. Don't make it harder than that. Okay, questions? All right, number 6. Now what do we want to do on number 6? So remember, and I will point out, that area model, don't forget, that area model is to help me what?
Multiply.
Multiply or distribute, right? So what we're really doing is we're distributing using this area model.
Dang it.
So what goes in the top up here?
3 minus
Does it have to be the 3 minus 2i?
No.
don't really matter. Not really.
That's
It
what I
could
had.
be either factor. I just want to make that clear. It doesn't matter. It's either factor. You don't have to put that one there. You could put the 3 minus 2i there.
Okay.
The one thing I'm going to caution, what I see students even in my first block making mistakes on is they're not paying attention to this. They put their minus here and then the 2i. But then it looks like 2i is what?
Negative.
Real.
Positive.
Positive. It can still work, but I always put my negative with the 2i so that it makes it clear that I'm distributing a negative.
Understandable.
Amber, are you not taking any notes to improve your understanding? Do you still have your demonstrate your understanding? Can you please do that too?
It's not gonna help me.
Fair, dude.
Then she's a little
Instruction.
Get to it.
Amber, you can multiply numbers. Okay. What's 3 times 1 then? What's 3 times 2i? 3 times 2i.
Oh, 6.
Gotcha.
Come on now.
Negative 2i times 1.
Negative 2 at that one, or negative 2i.
And then negative 2i times 2i.
Negative 4i squared.
Don't forget that it is I times I, so it is I.
You did negative 2i times 2.
Negative 2i times 2i.
Okay.
I ain't gonna lie, like, it get to it. I wasn't talking about that. I wasn't talking about that.
Okay? Now, I want to add my like terms, but I do want to remind you, before I actually move forward, what is negative 4i squared the same as?
4x squared.
I squared.
What is I squared?
Negative.
So remember, this is really negative 4 times negative 1, which is a positive 4. So it's important to remember when you get that I squared, the whole point is that I squared is negative 1. As soon as I see I squared, it's negative 1. And so I have plus 4. So 3, are there any like terms for 3?
No.
No.
There are now.
6.
Oh, yeah, 4. That's 4.
So remember, that's why we simplify and rewrite that negative 4i squared as plus 4, because 3 plus 4 is? What is 6i minus 2i?
Man, I got 3.8i.
Since I put 2 out, 8. Wait, you said
And
minus?
yours not.
Remember, that's a negative right there, Dewan.
I thought you said plus.
Yeah.
4i.
Okay.
7 plus 4i
Yeah.
is the final answer here.
I left my message on my paper.
Since we have the time, I do want to show you this. Can everyone pick up a calculator really quickly?
Yes.
Yes.
Okay.
Okay.
Mr. Kenny, can we keep this to study for testimony?
I was going to run downstairs and make copies of it and then return it to you, yes.
Oh my
That's why I
God.
wanted you to take notes to improve your understanding.
That green one.
Alright, so add a calculator page for me. Alright. Now, some students have noticed.
Okay, you gonna do 8.
Hey, can you just do what I'm asking you to do?
Thank you.
Okay, got a calculator
Oh, man.
page. Now, I want you to notice here, 3 minus 2, and you have the number I. Now, this will still work tomorrow, this part. Just taking the square root of negative 100 will not work on the calculator tomorrow. But what I'm about to show you will. 3 minus 2, you see the pi symbol down in the bottom left-hand corner next to H.
I don't see that.
Miss, can I ask you? How can you make these calculators do what you want me to do?
I have ways to change the settings and put them in a press to test mode.
That's crazy.
Okay, so you see the pi button down in the bottom left next to H?
No.
If you click that pi, then open your eyes, Dewan. If you click that pi, you'll notice here's the number I, not the letter I, the number I. So do 3 minus 2i,
Get that.
then parentheses, was it 2 plus 1i?
Yep,
Is that what it was?
no.
Why are you lying to me? 1 plus 2i.
We get
And then you gotta go to here.
Just gotta come outside.
And now I'm gonna hit the equal sign. 7 plus 4i. If these two things are equivalent, what should it tell me?
True.
What did that say?
It says true. So you can actually check yourself on your test tomorrow. Okay? The calculator will not be able to do the square root of negative 100 for you, but it will be able to check for you.
Mr. Kid, how you do that?
Do what?
The negative, what you say? Square root of negative, how you do that? How you do it?
The square root of negative 100 on the calculator. Remember, I'm turning that feature off. You got to be able to do the square root
No,
of
I'm
negative
telling
100.
how do you do it?
On the calculator, you type in the square root of negative 100.
But it says not a real calculation.
So some of the calculators do not have the right setting right now to do it. All right. So you can still check yourself tomorrow. Now, y'all stress me out with number 7. Number 7. This should be the easiest part of this. Should be. Now, I'm going to go ahead and tell you this right here and right now.
They're not adding.
For everybody who did something like this, that's not a number, that's a function.
No, we're not doing
We should not be drawing parabolas here. It is not a quadratic function. It's a number. It's not a straight line. It's not a function. It's a number. Remember, the x-axis is my real numbers. My y is the imaginary. So 1, 2, 3, 4, 5, 8, 9, negative 1, negative 2. So notice how those are all real numbers?
Yep.
This is 1i, 2i, 3i, 4i. And then going down is negative I, negative 2i, negative 3i. I don't think most of us did this, but literally in the directions it said make sure you label your axes.
I did that.
So 5 minus 3i means I'm going to the
Left. I'm in the right.
right 5 and
down left.
down 3.
Yeah.
1, 2, 3, 4, 5. 1, 2, 3.
Oh,
That is 5 minus 3i.
oh, we could just write
1
A beside
point. Huh?
it? Oh, just write A beside it?
You could have written a beside it.
Oh, okay, okay.
See, I ain't
I'm
think-
labeling it though as 5 minus 3i, because that's what it is.
My
I did that,
fault.
but I
Hey,
ain't know it
man.
was the way we supposed to operate like that.
I didn't write
I did that, but I ain't know that.
Now, I need y'all to pay attention to B, because if you did not get B, my guess is that you put it right here. If you put B right there, you need to pay attention to this again. Because that means you went to the right 4 and down 2. But what is 4i? Is that real or is that imaginary?
Imaginary.
So I need to go,
No, we gotta flip it first.
Oh,
isn't 4i all the way up here?
Yeah.
If you were saying left because of the negative 2, you are correct. Really, I would have written this in the standard way like this, negative 2 plus 4i. So
Oh, so
to
you
the
did that?
left 2 and up 4, that is negative 2 plus 4i. So make sure you identify your real and identify your imaginary. Last one. What's another way to write that to make it easier to see? Not minus negative 3, minus 3 times what? There's the square root of negative 1, so that is,
Come on, man.
Oh, okay.
guys, the square root of negative 1 is I. That is negative 8 minus 3i. So it is to the left 8, down 3. Make sure you are showing that information.
I got that right.
be doing all right.
Oh,
I did it.
I'm that guy.
I got the right points. I ain't got it. Oh, yeah, let's
Make sure you
clap.
label your
No, we're not
axes
doing
in the
that.
future.
This is not lunch.
Okay. What are your questions about number 7?
Get the freak off of me.
Yo, I feel like he be starting to.
She's starting, she using strong
Hey,
language.
Is I.
What are you talking about?
Okay. Anybody need me to repeat any information, any explanation?
Everything.
Yeah.
I play football.
He repeat everything.
Come on. If you were being serious, I would. Okay. Number 8.
Bro.
I need us to pay attention on number 8. I intentionally changed number 8 to help you better prepare for the test tomorrow, because I need us to recognize in number 8, first off, if it's asking for zeros, what do I need to do with k of x? K of x
Change the
is
zero.
0, right? I want a 0, so k of x is 0. Now I need y'all to pay attention to this, and if you did not recognize this, I need you to make notes about this. What form is this quadratic equation in? Vertex form, right? I've got vertex form. I see my variable one time. So what do I need to do to solve this equation?
Plus 6.
Inverses with properties of equality.
Yes.
Guys, if you see vertex form, if you see see your variable one time, you need to use inverses with properties of equality. The natural inclination here is to try to simplify this, but it's hard to simplify this. You could, theoretically, or realistically, get this to standard form. It would be a pain in the butt to get this to standard form. You do, actually, Maddie, we just haven't practiced it, but like, if you take x minus 3 squared, that's x minus 3 times
You
x
want
minus
to do
3. No.
Okay,
I was just saying, you can. So notice, like, I'm taking care of my exponent first, Maddie.
Look at the board.
I would take care of my exponent first. Multiply those out. Then I would multiply, then I would subtract. Like, it's what you've learned. We just haven't done anything like that with this one. No, I wouldn't. What am I gonna do? Inverses with? So like,
Inverse will
what's
probably
the
come-
first inverse that I should use here?
6
Why
plus 6.
plus 6?
You said why?
Yeah, why?
Because it's on the outside, I guess.
It's the outermost layer, isn't it?
Yeah.
Like, when I look at it, it's x minus 3, that's squared, that's times negative 2/3, then minus 6. That is the outermost layer.
So you gonna divide that?
Well, I wouldn't divide.
Okay, that makes sense.
You multiply with the.
Yeah, you could, hey guys, right now, so, let me write this reminder, outermost layer. That's a good call then.
I don't know later.
So outermost layer. So when I look here, I could divide, but do you want to divide by a fraction?
No.
I don't. Which is why I multiply by the reciprocal. What is negative 2 divided by negative 2?
Yo.
What's 3 divided by 3? So I made that a 1. This also makes my life over here easy. You can type this into the calculator, or what is 6 divided by negative 2?
6 divided by negative 2 is negative 3.
And 3 times negative 3 is?
It's negative 9.
You do get the same thing, but it's easier to do it by hand with multiplying by the reciprocal. So please hear me, and this is what we need to understand. There are lots of ways to do most of these problems. There's just, I'm recommending a certain strategy that I know is efficient. Now what do I need to do?
Oh, I'm
Thank you, Mel, say it louder. Square root it. Outermost layer is that square. And so what do I get from the square root of negative 9?
Oh, you get 3.
3i.
Ah. Oh, yeah, right, because 3, yeah,
That's
negative.
the square root of 9 times negative 1.
I like that out of you.
I'm trying to flow with it. Do that outside of class. We got some stuff to learn.
Bad out route.
You said we can do that outside of class.
What's wrong with you, bro?
Square root of 9, what is that? Square root of 9 is? 3. Square root of negative 1 is? I. So, Mr. King. Kenny, what? What's up, Deanna? You good?
Can I get out my pencil?
No.
No, I wrote the equation wrong, so I had.
She
I
heard
gotta
you
erase all
already.
that.
Okay. I'll look at it for evidence of understanding. Just write these corrections down.
Sit down.
Mr. Prince,
We good to go so far?
No, like
that's
the
the
equation
answer.
is wrong on my paper. I wrote it wrong.
It's okay. I will look at it. I will. Hey, listen, Jamie. What I'm telling you is, I will read with the fact that you miswrote it. I can see that. Just write the corrections for this down. Is this good to go in black?
I wrote you a note.
You wrote me a note. Y'all, you're forgetting a key thing here.
What did we miss?
Oh,
Yeah,
wait,
square
the,
root.
dance anybody?
You gotta see it.
I'm talking about, is this okay right here?
Yeah, you gotta
It's
switch it.
imaginary.
Into the X.
Bro,
Didn't
bro,
say that.
bro, yes.
I said hurry.
Says what?
Okay, can I go back? Hey, y'all.
Hey guys, how many roots is this quadratic supposed to have?
2.
Plus or minus.
Guys, when you take a square root, you need the positive and the negative. Because both the positive and negative would have made that equation true. Now,
We still gotta keep on going?
well, you gotta know what x is, don't you?
Yes.
I hadn't finished finding x. I had x minus 3, but I didn't have x.
I feel that.
Bakari, you're trying to solve for x, right? Did you finish solving for x? Did you have what x was equal to right here? Now remember, that's why I look for evidence of understanding. J Mike, you awake? We got one more we gotta do.
I thought that was the last one.
We got number 9.
Hold on, cause I could've sworn you said that the last one.
Nah, he meant on the
I
left.
never
Hold on.
said that. There's a
was
number
zero.
9 on the paper,
I could have
dude.
sworn you said it was the last one.
No, y'all thinking when I said on number 8 for C, that was the last one.
Oh, okay.
So, first off, we need to recognize what form is this quadratic in. It's in the standard form, right? So what do I want to use if it's in standard form?
You want to use
The
quadratic
quadratic
formula?
Why can't I right now?
Because it got to be equal to
Yeah,
0.
gotta
It's
be
got to equal 0. So what do I need to do over here to make it 0?
Add 5.
Add 5,
Add that
cool.
5. Yeah.
Anything else?
On both sides.
Add it to that 3. Yeah.
Anything else?
Subtract 3x.
Oh, true speak.
Right? You can do it as 2 separate steps, but I would go ahead and do it at the same time. Now what do I have on the left-hand side?
X squared plus 8x.
Left-hand side.
Oh, 0.
Left hand
But then after
0.
the 30.
That's fine. But if you look up here, on the left-hand side, we got 0.
Okay.
It doesn't matter which side it's really on. But using the math that's up here, this is what I get.
40 ball.
Now,
Okay, I did it.
I can use the quadratic formula.
Okay.
Let's go.
Be careful, because I saw a lot of people missing that plus or minus. That plus or minus matters.
The 1.
Take the time to identify A, identify B, and identify C.
Why you cut my hair?
Weird. 8, yeah,
Savage
squared,
justification.
yeah.
He said
Oh,
cut my hair.
40.
Barbershop.
We ain't got
She took her remember Ariana Grande shirt.
Was that 64 minus 172, so negative 108?
Dang, oh. I only wrote 72.
Little boost.
Dang. We just 64 minus 72?
He cut my hair away.
Is that a minus?
All you gotta do is put in your calculator.
Keep it.
You just went so fast. You just didn't see.
Man.
Okay, we're not gonna do it. You gotta keep it.
Don't get mad.
Don't give me that extra minute.
Instead of washing it.
What you put in that
Cut
calculator?
my hair
Cuz ain't no.
away.
That's not
Come
washing.
on, Birdie. Come here.
Right, right. Where's the marker?
Mr. Kenny go.
Alright, so 6, root 3i, all divided by 2. I apologize for having to finish that up, because I got 3 minutes. I need you to put your demonstrate your understandings together so I can go make, hey, hold on. I'm gonna go make scans and I'm gonna hand it right back to you so that you can finish whatever notes. I need you to put your demonstrate your understandings together.
Oh, no, Mr. King. You might not finish.
Hey, you're gonna get it back.
Dude, I'm not even doing.
You're gonna get it back. But I gotta make, do you want this before your test tomorrow?
Hey, brother. Hey, brother man.